Well, hello and welcome to class number 7. I'm number 12, and today we're going to cover sections 6.4 through 6.6 in the rate of return analysis chapter. Again, we use ROR for rate of return, or I star is the effective interest rate that is the rate of return. I will be posting an updated schedule of assignments, estimated schedule of assignments, but I'm going to try to complete it through the remainder of the semester soon. So be on the lookout for that. We're going to be covering pages 162 to 174 in your text. We have a lot of material to cover today. So I will let you read through all the rest of this, and I'll produce another video working some end of chapter problems, but there won't be any time in this particular video because we have so much material to cover. So in section 6.4, we present, or the author presents a procedure for doing an incremental analysis. As we said in the previous class, class 11, that with rate of return, you cannot just select the alternative, the mutually exclusive alternative with the highest value, like you did with present worth, annual worth, and future worth. With rate of return, you have to use what we call an incremental approach. That is, you have to get the difference between the cash flows of the alternatives and compare the rate of return on that difference in cash flows with the MAR, the minimum attractive rate of return, and then you'll be able to make a decision which alternative to select. The author starts by saying that if you can select more than one alternative, which is what he really presents in this section, so if the alternatives are not mutually exclusive and you could select more than one, he says that the rate of return of the combined set of alternatives is the weighted average rate of return of the individual projects in the alternative. So, for example, suppose we had investment A that had a rate of return of 20% and an initial cost of $10,000. Investment B, which is also possible, we could do both A and B. It has an initial rate of it has a rate of return of 30% and an initial cost of $40,000. And then I added in alternative C, which has a rate of return of 40% and an initial cost of $50,000. Then the average rate of return, if you did all three of those projects, would be I star of ABC equals the weighted average. So we're going to take 20%, that's the rate of return on A, times its initial cost, and then take the percent rate of return on B times its initial cost. Do that also for C, rate of return times its initial cost, and then divide that by the sum of the cost of all three alternatives, or however many you have. And if you do that, you can see that the first multiplication, 20% times $10,000 is $2,000. The next one is $12,000. The next one is $20,000. You add those three together, you get $36,000 over the total cost of doing all the three projects, which is $100,000, gives you 36%. So that's the weighted average rate of return if they were not mutually exclusive. For example, suppose your MAR was 10% and each of those could be done. Well, they all have a rate of return greater than 12%. So, 10% greater than the MAR. So you would want to do all three of them, and this gives you the rate of return on the three of them. This incremental approach, by the way, is used when they are mutually exclusive, so that you can only choose one or none of them. Okay, so when we have two or more mutually exclusive alternatives, then what we want to do is look and see if there are revenues. If there are revenues, then we do consider the do nothing alternative. And of course, that would be the lowest costing alternative. So that would be your first one listed, so to speak. And then we will do the incremental cash flows. If there is no revenues, and we'll give an example of that in a little bit, then all you're looking at is the various costs. And so that implies that you're going to do one of them. The do nothing alternative is not feasible, okay? Because if there's no revenue, there must be a reason you have to do one of them. We're going to come up with a procedure. The first thing you do is order the alternatives and decide whether or not you're going to need a do nothing. And then the second thing is you line them up according to the incremental cash flow. According to the initial investment required. And then you find the rate of return of the next lowest costing alternative minus the lowest costing alternative. Say I had A, B, C, D, then I would be comparing B and A first, okay, B minus A, and I'd get the incremental cash flow, find the incremental rate of return. If it's greater than the MAR, you select the higher costing alternative B. If it's less than the MAR, you select, I'll say greater than or equal to, you select B. If it's less than the MAR, you select the lower costing alternative, which is A. Once you selected one of those two alternatives, you go to the next higher costing alternative, and this will become clear when we work a couple of examples for you. So let's do that next. We have an example here where we're trying to decide between four machines, A, B, C, and D. We have a MAR of 13.5%. This is example 6.6 in your smart book. And then if you look at the cash flows, machine A has a negative or an investment cost of $5,000 right now. It has annual operating costs of $3,500, and the only revenue is the salvage value. So when the only revenue is the salvage value, we consider that a non-revenue problem. It's only looking at mainly your operating cost and your initial costs. So in that case, we're not going to consider the do nothing alternative. B is the same way, different numbers, but basically the same structure. A negative initial investment, negative annual operating costs, positive salvage value. By the way, they're all 8 years. So we're going to line these up according to the lowest cost first. So that would mean our lineup will be A, followed by B, followed by C, followed by D. In this case, the letters of the alphabet work just perfectly because this is the lowest, A is the lowest, B is the second lowest, C is the third lowest, and D is the fourth lowest, or the highest, basically. So we're going to now compare B with A, compare the first two, and we get the incremental cash flow, the cash flow of B minus the cash flow of A, okay? So let's look at it year by year. So in year 0, we're going to have the cash flow of B minus 6,500 minus the cash flow of A, which is minus 5,000, which will yield us, that's going to become a plus, a minus, that's going to be minus 1,500. So that means the incremental investment required to do B versus A, the additional investment is $1,500. Well, what's the additional cash flow in years 1 through 8? So the cash flow of B in years 1 through 8 is minus 3,200. And I'll subtract from that the cash flow of A, which is minus 3,500. That's years 1 through 8. That's going to be a plus. This is a minus, so that's going to be a plus $300. And then in year 8, we're going to do the salvage value. B's salvage value is 900. And we're going to subtract, that's a plus, and this is a plus, so we're going to subtract the plus 500. So that will yield us plus 400. And we'll keep the salvage value separate, even though there is a cash flow in year 8 as well, 1 through 8. So here we have the incremental cash flow now. And what we want to do is take this, set the present worth of that equal to 0, and solve for the interest rate. That's going to be the incremental rate of return. So present worth of B minus A at some rate I star B minus A equals 0 is our basic equation. And now we'll plug in numbers. We'll get minus 1,500 plus 300 P slash A, some unknown rate for 8 periods, plus 400 P slash F, unknown rate for 8 periods, set it equal to 0, solve that equation for I. And when we get the solution, which I'll show you on the next page, the solution to that is I equals 14.57%. So I star of B minus A is 14.57%, which is greater than the MAR. The MAR is 13.5%. So we select the higher costing alternative, B. If this was, if our rate of return for the incremental cash flow was less than the MAR, we would select A and do the next comparison. But since we select B, the next comparison will be C minus B. And so what we're going to do now is we went through all these steps. We went through steps 1, 2, 3, 4, 5. We're going to go back up and start with step 2 again and look at the incremental rate of return of C minus B. And the author does that here in this spreadsheet. He shows us that the incremental rate of return of C versus B is a negative 18%. So what does that mean? It means select B, okay? B survives, he says. I prefer to say choose B over C. And then the next comparison then will be D versus B. And so the author goes through that, shows you the incremental cash flow and does the rate of return. And he gets 13.6%, which is just barely greater than the MAR of 13.5. So in that case, we choose choose D. And that's the end of the process because we've covered all of the investments. And that's a case where you had no positive cash flows except salvage values. And we had equal lives for the alternatives. The next example 6.7 in your textbook is a little more complicated because you do have positive cash flows, so you do have to consider the do-nothing alternative, and you have to line them up as well because they're not prearranged in the right order, so to speak. So notice that the initial investment of project 1 is minus 80,000, project 2 is minus 50,000, project 3 is minus 145, and project 4 is minus 20. So actually your do nothing alternative, since we do have to consider it because we have revenue streams, is just all zeros, okay, for however many years. And notice also we have different numbers of years. Now, we only have to worry about the different numbers of years if we're comparing two alternatives that have a different number of years. So the first comparison first thing we're going to do in step 1 is line them up, okay? So do nothing is the least costing alternative. The next least costing is 4 minus 20,000. The next one is going to be 2 minus 50. The next one is going to be 1, which is minus 80. And then finally, the most expensive one is minus 145,000. And so that is the order that we need to compare them. So the first thing we're going to do is compare 4 versus do nothing. Well, 4 versus do nothing, since do nothing is no cash flow, is just 4 by itself. So we want to see if the rate of return on 4 is greater than our MAR for this particular example, which is 12%. So notice on number 4, you have an initial investment of 20,000. You have annual operating costs of 21,000. That's dollars per year. You have annual revenue of 29,000. Well, that's going to leave you a net cash flow of $8,000 a year for those 4 years, okay? So your present worth equation is going to be minus 20,000 plus this differential, which is 8,000, P given A, the I star, and 4 years. And if you solve that equation, you'll get 21.9%. So that means that's greater than the MAR, so we choose 4 over doing nothing. If this was less than the MAR, we'd choose do nothing and then compare the next one, which would be 2, to doing nothing. But in this case, it's greater than the MAR, so we choose 4, and now we're going to compare 2 versus 4. So the author does that. The initial is you got minus 50 minus a minus 20 yields you minus 30. And so that is, let's see, I don't think he goes through the cash flows for you. So you're going to have to start with minus 30, and then this is 8,000, recall the net value, and the net value of this is going to be 17,000. And when you do the rate of return, both of those are 4 years, by the way. When you do the rate of return analysis on that one, 2 versus 4, you find out that the rate of return on that cash flow of minus 30,000 plus 9,000, this 9 was the 17,000 of 2 minus the 8,000 of 4, which is 9,000. That's 17 minus 8, which is 9. And so you do the rate of return, you get 7.7, which is less than the MAR. What do? You choose the lower costing alternative, okay? So you choose 4 rather than 2. So 4 survives, or choose 4. And then the next comparison then is going to be 1 minus 4. So I do the analysis of that. If you look at 1 it's a 4-year project. 4 is a 4-year project. This is minus 80,000, and this is minus 20. So that's going to be a minus 20. So that's going to leave you minus 60, and then you have net cash flow. Here is going to be 33,000 minus 8,000, which is 25,000, and you do a rate of return on that, and you get 24%, which is greater than the MAR, so you go with the higher costing alternative, which is 1. So this says choose 1. And now we do the last comparison, which would be 3 versus 1. And you do that comparison, and I won't go through all the details on that one, after having gone through so many. Can't get these papers separated. There we go. You do the 3 versus 1. You get 10%. I forgot to mention, that is a difference when we compare 3 with 1. 3 is an 8-year project, and 1 is a 4, so we have to do the least common multiples. That means we have to repeat this 8,000 after 4 years. So that does put a little extra wrinkle in this, so I will go through it. So you have the cash flow from alternative 1 at time 0 is minus 80, and also there's a minus 80 at time 4, and the cash flow each of the 8 years will be plus 33,000. For alternative 3, you have the minus 145 at time 0, and you get plus 35 throughout the 8 years. And so we'll have a minus 145 minus a minus 80 at time 0, which is minus 65. And then at time 4, based on the initial cost, you have 0 here, but you have a minus 80, so that's a plus 80. And then each year you have a plus 2. When you do the rate of return analysis on this cash flow, you get 10%, which is less than the MAR. So you go with the lower costing alternative. So choose 1, and now you're finished. Okay. So the last thing I will do is look at the section 6.5. Is that the last? I think so. And there is a case where we get to having more than one rate of return. In other words, when you set up the rate of return equation, present worth equal to 0, more than one value of I satisfies that equation. Of course, we're only interested in real positive values of I, but sometimes there's more than one real positive value of I. Nordstrom's criterion tells us when we don't have to worry about that, basically because there's only one. And his criterion says there is one real positive I star value if the cumulative cash flow, now cumulative cash flow is designated as S0, S1 up to Sn, where the S value is the sum of all the cash flows through that year number T. Okay, so S of J is equal to the sum T equals 0 through J of A sub T. It's the sum of the cash flows. If that particular cash flow series changes sign only once and S0 is negative, so that means it starts negative and it changes to positive and it never changes back to negative. In that case, you will have one real positive I star value, which is what we kind of like. But the next example, 6.8, is where you don't have that. For example, suppose your cash flow, this is A sub T along the first row. The first cash flow is plus $2,000 at time 0. Well, right away, you realize that this cash flow does not satisfy Nordstrom's criterion, because this Nordstrom's criteria requires the sum of the cash flows up to time zero be negative. Okay, so remember, S sub 0 is just going to be A sub 0. That is the cash flow at time 0. S sub 1 is going to be A sub 0 plus A sub 1, and so on. This does not satisfy Nordstrom's criterion. And then you can see it is negative, then it changes to positive. So that's one sign change. And then it stays negative, so that's still one sign change. But then it changes back to positive. Has two sign changes. And so the cash flow of the S's, which is what we're looking for, this is positive, so we missed that criterion. And here you got a plus, plus, minus, plus, two sign changes, so we missed this, only one sign change. Neither of them hold, so we do not have his criterion satisfied. So there may be more than one real positive rate of return for this cash flow. Don't confuse like I did a little bit, the sum of the cash flows, the S's, with the actual cash flow, which we call A sub t. So if we want to find the rate of return for this cash flow here now, we must realize there may be, because Nordstrom's criterion is not satisfied, there may be more than one of them. And in fact, that's what the author shows you in this graph. If you plot the present worth versus the interest rate, it starts up here at a very positive value. It crosses the I-axis down here. Let's see, where's the I-axis? 0. It crosses here, but then it comes back up and crosses here again. So you have two rates of return, two values at which the present worth of this cash flow, two values of I, equals 0. And when that happens, we really don't have good methods of dealing with that. Now, the author does present in section 6.7 and beyond some alternative methods, but I'm not going to go into those. What I'm going to do is produce another video with some homework problems solved. Well, first I'll do some end of the chapter problems, and then if time permits, I'll work some homework assignment problems. And that's the end of today's video. Thank you.